Good morning, dear students. So, this is part 3 of the chapter Motion, and the next topic is Rate of Change of Velocity. As you all know that during uniform motion of an object along a straight line, the velocity remains constant with time. In this case, the change in velocity of the object for any time interval is 0. However, in non-uniform motion, velocity varies with time. It has different values at different instants of time and at different points of the path. Thus, the change in velocity of the object during any time interval is not zero. So, how can we express this change in velocity? So, I'm going to discuss the new parameter, and that is acceleration. It is given by rate of change of velocity. Suppose the initial velocity of the object is u and final velocity of the object is v, and the time taken by the object to change its velocity from u to v is t. Then acceleration will be given by v minus u upon t, that is rate of change of velocity. Fine. Now what will be the SI unit of acceleration? SI unit of acceleration is meter per second square, as you can see from the formula also. Now the velocity is changing. Either it can increase or it can decrease, right? In the case of velocity decreasing, that case will be known as the case of retardation. When the velocity is decreasing, that case is known as the deacceleration case or the case of retardation. Therefore, acceleration can be positive and negative. Also, acceleration is a vector quantity. Now, if an object travels in a straight line and its velocity increases or decreases by equal amounts in equal intervals of time, then the acceleration of the object is said to be uniform. On the other hand, an object can travel with non-uniform acceleration if its velocity changes at a non-uniform rate. Next, we will study about the equations of motion by graphical method. When an object moves with a straight line with uniform acceleration, it is possible to relate its velocity, acceleration during motion, and the distance covered by it in a certain time interval by a set of equations known as equations of motion. These three equations are v is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to 2as. Now we will derive these equations graphically. Here I have plotted the graph between velocity and time of an object, and the curve which I got is Pn. Let initial velocity of the object be u, which is given by the line segment OP. And final velocity of the object is given by v, which is given by the line segment nr. Now I'll find the value of nq. As OP and QR are equal, therefore the value of QR will be u and that of nr is v. nq can be found out by subtracting nr by QR. So nq will be equal to v minus u. And the time interval is represented by OP, which is given by t. And the values of, sorry, not OP, OR. Okay. And the values of OR, PQ and MN are equal, and that is t. Now, deriving the first equation of motion, we will just apply the formula for acceleration, and that is change in velocity upon time. Fine. So A is given by v minus u upon t. Now rearranging the terms you will end up in the equation 2. V is equal to u plus at. Now I will derive the second equation of motion. Now you all have to memorize one thing, that the area under the velocity time graph will give you the distance traveled by the object. Fine. So here Pn is the curve, that is velocity time curve. So you need to find the area under this curve. How can you calculate? You can add the areas of rectangle PORQ and area of the triangle PNQ. Area of the rectangle will be given by length into breadth, and area of the triangle will be given by half base into height. So I have just substituted the values. You can check the calculation I have sent in the notes also, and you will end up with the second equation of motion. Fine. Also, you have to note one point over here is that I have substituted the value of v minus u from equation 1. Okay. Now I will derive the third equation of motion. Area can also be found out by another way. We can calculate the area of a trapezium. So area of trapezium is given by half into sum of parallel sides into height. And substituting the values, you will get this result. And rearranging the terms, and I have substituted the value of t again from the first equation of motion, and at the end you will get this equation, which is the third equation of motion. So that's it for today. I'll send the next part soon. Thank you.